Greetings to all and a very warm welcome. Viewers, I am John and you are watching John Visual Physics. In this video, we are going to see torque on a current carrying coil and a magnetic field. First, we see the practical model of torque on a current carrying coil and a magnetic field. In this model, we have a rectangular coil placed in a magnetic field. The plane of the coil is parallel to the magnetic field. 1 ampere DC current is passed through the coil. Magnetic force rotates the coil about a fixed axis. This rotation of the coil is torque produced by the magnetic field. Why does the coil rotate? To answer this question, we know from the previous video that when we pass an electric current through a wire placed in a magnetic field, a magnetic force acts on the wire. The same physics apply here. When current is passed through a coil, magnetic field is produced in the coil. Due to the interaction with the external magnetic field, the coil rotates. How does a coil rotate? To answer this question, keep in mind that a rectangular coil is equivalent to 4 conductors A, B, C and D placed in a magnetic field. Maximum magnetic force acts on a conductor which carries current perpendicular to a magnetic field, while no magnetic force acts on a conductor which carries current parallel or anti-parallel to a magnetic field. When the plane of the coil is parallel to the magnetic field, then current along C is parallel to the magnetic field, while the current along D is anti-parallel to the magnetic field. Therefore, no force acts on the sides C and D. Current along A and B are perpendicular to the magnetic field. Therefore, maximum magnetic force acts on the sides A and B. The magnitude of the force is equal to ILB sine theta on each side. The direction of the force on each side can be found using the right hand rule. Point the fingers of your right hand in the direction of current and curl the fingers toward the magnetic field. Your thumb is in the direction of the magnetic force on side A. The force is out of the screen on the side A. Similarly, using the right hand rule, the force on the side B is into the screen. Forces on the sides A and B forms couple. Maximum torque is produced when the plane of the coil is parallel to the magnetic field. When the plane of the coil is perpendicular to the magnetic field, no torque is produced. For this position of the coil, all the sides A, B, C and D are perpendicular to the magnetic field. Magnetic force on each side is ILB sine theta. Using the right hand rule, we can see that the forces on the sides A and B are along the moment arm. These forces balances each other. Similarly, the forces on the sides C and D are along the axis of rotation. These forces also cancel out each other. For horizontal position of the coil, the sum of all the forces acting on the coil is 0. Therefore, no torque is acting on the coil. When the plane of the coil rotates from vertical to horizontal position, it continues its rotational motion due to its rotational inertia of motion. Viewers, if you haven't got any point, write in the comment. Please subscribe the channel and don't forget to share. Thanks for watching.